All right. Good evening, everybody. Good evening, everyone.
Evening, sir.
Evening.
Good evening, sir.
Everyone. Evening, everybody. Oh, why is my charger? Oh, Lord. Give me a second, guys. What is happening? That's so I left it on charge. Okay. All right. Wonderful. Hope everybody's safe. Only 17 persons are here. Oh, no day. Okay, ladies and gentlemen, a couple of updates. Good evening, Letitia. A couple of updates before we jump into it. Remember, today is our final class in the grace period. So I see some of you guys are sending me some pictures. As soon as I've created the link for next week's class, I will send it to the individual persons who have sent me the pictures of their class pass. All right. So next week, this link is null and void. It's no longer active after this class. All right. Secondly, I guess some of you guys would have seen the poster that I posted in the group. Let me see if we can find on the phone here. Give me a second there. It would have been in this. All right, so you guys would have seen this poster. You guys would have seen that today?
Yes, sir.
All right. So
Yes, sir.
that's all the information that you guys need, I guess. Any questions you may have, you know, my phone is always open. You can always address it. I'm not sure if everybody here is going to be coming online or face to face. If you notice that there's a couple of differences in the prices because the package prices have the discount in it already. So I don't know if you want to pay on the day. That's up to you because some persons may not necessarily come to all 7. They may come to 5 or 4 or 3. So if you know you're not going to come to all 7, it doesn't make no sense to pay for the package price. But if you want to come to all 7, you can. And remember that what I teach face to face is not what I teach online. Are 2 different papers. Everybody get them different preparation process. So if you look under the marathon package deal, number 2, you see online face to face. As you can see, for the online students, it is 10. The reason why it's 10 is because you guys are not physically getting the material. So it wouldn't be costing us to print it. So that's why you guys are paying a little bit less than the persons who are paying face to face. But if you want to, for some people, I don't know, there are persons who believe that they need double dose. So for the persons who want to come online and still come to face to face, you're gonna get double hours for only $3,000 extra. So that's entirely up to you. So you'd be doing, what would it be? You'd be doing 12 hours of maths every weekend. So read through the information carefully, and then if you're going to go for a package deal, then you just go to the office and let them know that you want a VIP pass. All right, because the marathon package VIP pass. But if you're just a student who is coming on a specific Saturday, then you just come on the day and pay the funds on the day. All right. Any other questions that you may have, feel free to message me about the details. All right. All right, cool. You know, to send, and remember to send the information to the school. Don't send it to me because I am not in control of this marathon. Okay. All right. Lovely. All right. So we get those 2 things out of the way now. What are we doing tonight, Miss Gentles? You're me like a secretary, What did we do last?
Last class we did direct functions, input and output.
Okay. That's where we're at. Lovely. That's last week Wednesday, correct?
Yes, sir. Yes.
Lovely. Let us do a quick recap. Let us do a quick recap on this. So we did so did we get to undefined functions or we didn't get there? Did we
No,
touch anything?
sir, we didn't.
Oh, we didn't. Okay, noted. All right, let's go. So this is what we're going to be doing. So we're going to do a quick little recap on what was taught last week for those who were not, unfortunately, were not here. All right. Oh, and just I remember that all the marathon classes are being recorded, you know. But it's just that the recording won't be posted live on YouTube. It will be sent to you upon request as a private link for you to watch upon request. So if it's a case where after coming to the online marathon, you still want to go back through the marathon throughout the course of the week, you just request the recording link and it will be sent to you. All right. As long as you are an online student, so you can always come to the live marathon and then you can actually request the link privately. It's going to have a code, so only you can access that link using your personalized code, right? So if you send the link to somebody else and they click on it, it's going to show them that the video is not there. All right, cool. So last week we introduced the concept of f of x. Example, f of x is equal to 4x plus 7 over 2. And let's say we have g of x.
Sir,
Yes, there.
last week's class is already uploaded on YouTube.
Pardon me?
I'm asking if last week's class is uploaded on YouTube.
I think so. I think I might have uploaded the last one Sunday evening. So I think so.
Yes, I saw it.
Okay. So yeah, man. So this, I think this that we're doing now, this recap, I think I uploaded it Sunday evening at 7 o'clock. So it's the last post I made. And g of x is equal to x plus 5. Lovely. All right. And so the questions that they can ask you are, 1, they may ask you to work out what is f of -3. Or they may ask you to work out something like g of, say, a quarter. All right. And they may therefore go ahead and give you like a question, like an output input question. So they may ask you to work out the value of x. So they may say, find the value of x for which 1, f of x is equal to 2/3, and they may say g of x is equal to -10, something like that. All right. So depending on the complexity of these two functions, depending on how it looks, it will determine how the working out goes. All right. So there's not a set working out for this type of problem. All right. So let's work out f of 3, f of -3. This means that we're going to take -3 and put it right where the x is right here. So we're going to end up then with 4 times -3 plus 7 over 2. So this works out nicely to be 4 times -3 is -12 plus 7 over 2. And when we work out that, we're going to end up with -5 over 2. All right. Lovely. Now for the next one, g of a quarter means that this is going to be, you're going to replace the x right here with a quarter. So we're going to have a quarter plus 5. So a quarter plus 5. So with a quarter plus 5, you can write 5 and a quarter if you want to do that. Or I would rather you just put this over 1 and find the LCM. 4 into 4 goes 1 time. And 1 into 4 goes 4 times. 1 times 1 is 1. And 4 times 5 is 20. So we end up with 21 over 4. If you want to put it to a mixed fraction, that's up to you. I'm quite comfortable with 21 over 4. All right. So this now, those two questions there is what we refer to as the input output. You input something into the function and it produces an output. The one down below here now is the one we call output input. So the output input is where you are provided with the output and you have to calculate what the input was. What was the number that was placed in the function to produce the output of 2/3? So in this case now, what we do is we simply replace this symbol right here, all of this symbol, with 2/3. So if we minimize this a bit here and zone out like that, notice right here, ladies and gentlemen, that this symbol right here will be replaced with 2/3. So we're going to replace this symbol right here with 2/3. We're going to end up with 2/3. And that's going to be exactly equal to 4x plus 7 over 2. All right, because this is now f of x. So it's just, so basically what it's saying is that it's basically saying f of x is equal to 4x plus 7 over 2. That's what it's saying. All right, now, how do we go ahead and do this? We can go ahead and cross multiply. So we can go ahead and say this times this, followed by this times this. All right, or you can multiply both sides by 6. It's up to you. All right, so let's go ahead and do that. We're going to start off with this side right here. We're going to say 3. Let's zoom it up for you a bit. So we're going to say 3 times 4x. That's going to give us 12x. And then we're going to say 3 times the 7. So 3 times the 4x, 3 times the 7. That's going to give us 21. And then we're going to end up with the final one. 2 times 2 is 4. 2 times 2 is 4. All right, bring this over here. We're going to end up with 12x being equal to 4 take away 21. Okay, you carry it over, so you change signs. So 12x is equal to negative 17. So x then works out nicely to be negative 17 over 12. Okay, divide both sides by 12. And that's it. So that is the output input function.
Sir,
Yes, Akisha.
where did you get the 21 from?
Oh, 3 times 7. You use the 3 down here to multiply the 2 terms up here.
Oh, okay.
All right, now we end up with g of x is equal to 10. If we zoom out here and go back up to the top here, we can see this g of x function right up here. But we can also see the g of x right here. So g of x is now 10. So that means this number will be replaced with 10. So 10 would be equal to x plus 5. So we're going to end up with 10. Or is it negative 10? Or it's negative 10. All right, so no problem. So negative 10 is going to be equal to x plus 5. Bring the 10 over here. Oh, hold on. We don't want that, do that. Instead of bringing over the 10, bring over the 5 instead. So we're going to have negative 10 minus 5 equals x. So negative 15 equals x. And that's it. So those are some examples of what we call input-output function. All right, lovely. Fantastico. Now, closing off that part now, I will deal with the undefined function at a later date, maybe when I'm finished with this section, because I don't want to use the class and deal with that just yet. So I'm going to move to the, did I give you like a list, guys? What comes after undefined functions? I think I gave you a list last week.
Sir, you gave us undefined first, then composite second.
Okay, so undefined is supposed to come second, right? You know what? Let us do it. We're not going to skip it. Let us
No
do it.
lies. So it's direct, undefined, and composite.
So direct, undefined, then composite. So we finish with direct now. Input and output, output and input. So we're going to go to undefined now. All right. So, undefined functions. Undefined functions. All right. Now, let us first have a arithmetic understanding of undefined function. I don't want to just give you a function and then tell you that this is how you know it's undefined. I want to explain to you arithmetically before we get into it algebraically. Okay? So, here's what we're going to do. I want you guys to help me out. I need some help. So, I need the help with your calculators, right? So, what I'm going to do, I'm going to pick a number. I'm going to pick, say, 1,000. And I'm going to divide 1,000 by numbers below 10. All right, so I'm going to start by dividing 1,000 by 10. I want you to tell me the answer. What's 1,000 divided by 10?
100.
All right, 100. All right, I'm going to take the 1,000 again. And I'm going to divide 1,000. This time I'm going to divide it by 8. How much you got?
800.
125.
125.
1,000.
All right. And then what I'm going to do now is that I'm going to go ahead and divide the 1,000 by 6. How much you got?
166.
0.67.
0.666.
0.7.
That's recurring.
Well, Dr. Seven.
Yes, sir.
All right, so 166.666 recurring, so 166.67. All right, cool. We're going to go ahead and divide it by 4.
250.
All right, and then we're going to go ahead and divide it by 2.
500.
All right, lovely. All right.
500 or 5,000?
500. 1,000 divided by 2 is 500. 2 500 make 1,000. All right, and then we're going to go ahead and say 1,000 divided by 1. 1,000. Not sure? All right. Going a pattern now. Zooming out. Now, we're going to go to numbers now that are less than 1, but it's not negative. It's approaching 0. So we have 1,000 now divided by 0.5. How much you got for that?
2,000.
2,000. All right, and then we're going to have 1,000 divided by 0.2.
5,000.
5,000. All right. All right, now we're going to continue. I'm creating a pattern because I want you to see what when us math teachers tell you about if and when you hear this word again, I want you to not just understand just by working a question. I want you to understand what we mean by undefined function. What does it mean when something is undefined? Right? So 1,000 now, we're going to divide this by say 0.1. How much you get?
10,000.
10,000.
All right, better 2 more. So you see what going on. Now 10,000 you say? All right, so 10,000. So now 1,000, watch me now, divided by 0.001. How much you get?
1 million.
1 million. All right, now stop here. So I'll show you what the pattern, what's going on here. So 1 million. Hold on. That's a 1 million, right, Mr. Peart? I don't want to get rich. All right, 1 million. Now, I'm going to use my red marker. I want to pay attention to what's going on here, guys. So I took a random number, and this that I'm doing here can be done with any number. I took a random number and I used it 1,000, right? I started off by dividing it by 10. And the numbers that I'm dividing it by is getting less and less and less and less and less. And it's getting less and less and less. But what you notice here is that as it gets less and less and less, it's actually approaching 0. It don't reach a 0, you know, but it's approaching 0. So notice that every number that I divide 1,000 by, the number that I'm dividing the 1,000 by is getting closer and closer and closer to 0, but it's not 0. So if I were to say what is 1,000 divided by 0.0000000000000000001, I'm going to get such a large number that the calculator will not be able to write it on screen. Because as you notice here, that as I'm dividing by a number that's less than 10, the answer is getting exponentially larger and larger. My first answer was 100, 125, 166. See, it's going up, it's going up, it's going up. And then right just now, it starts to rapidly increase. Because look, it was 100, then it go up by 25, then it go up by 30 something. Then it jump up to 250. Then it got doubled right here. Then it got doubled here. Then it got doubled here. Then it get doubled plus 1,000. Then it get doubled here. Then it get what? Wicked. It is fly right up. So what is happening is that as I'm dividing by a number that is less and less, or as I'm dividing by a number that's approaching 0, my answer is getting larger and larger and larger exponentially. So what that means is that when I get to the point where I actually try to divide by 0, the number is going to be so big that we can't record it. Therefore, that's why we say you cannot divide a number by 0. It's not that you can't. You can. You can divide a number by 0. But as you can see, look at this. This is just 1,000 divided by 0.0018 million. So what do you think is going to happen when I say 1,000 divided by 0.000000001? What do you think is going to happen? You're gonna the gazillion, zillion, one whole per illion, right? So the number is getting exponentially larger and larger and larger. It's getting so large to the point where no applications can store this number except a supercomputer. It's too big. So therefore, because the number is so large, mathematicians just basically say that whenever you divide by a 0, the result is undefined. That's why we say down here that you cannot divide a number by 0. That's what they're saying. All right. Now, how using this information now, right? Now that we can confirm, right? We can confirm that it is impossible. It is impossible, Latisha. Your cursor is in the way, love. Thank you. So it is impossible to divide it is impossible to divide a number by 0. Hence the result is undefined. That's what us mathematicians came up with and say that it is undefined. So how does this help us with this f of x, g of x, h of s thing? Here, let's zoom in back for you. So then now, what are we looking at? We are then simply saying that if I give you a function, let's say I give you a function and I say f of x equals 5x plus 3 over x plus 1. And I say to you, state the value of x for which f of x is undefined. What this means, ladies and gentlemen, is that they want you to tell us or tell them what number has to go right here so that when you work out the actual calculation, you get 0 at the bottom. That's what they're trying to find out. What number would need to go? What number would need to go right here? So what number would I have to put right there so that when I work it out, I'm going to get something over 0? Because remember, so when you have something over 0, this is undefined, as I just demonstrated to you. So the examiner is wanting you to tell them what number should be right here where the x is, so that upon calculation, we're going to end up with a 0 at the bottom. How do we answer this question? You're not going to do that long thing I just showed you, No. All you're going to do, ladies and gentlemen, is that you're going to take the denominator and equate it to 0. Therefore, x must be equal to -1. The only way for you to get 0 at the bottom here is for x to be -1. Check it out. 5 times -1 plus 3 is equal to, over -1 plus 1. Now, -5 times -1 is -5. We're working good. Plus 3 over -1 plus 1 is what? 0. But we don't establish from this thing over here that we were discussing earlier that due to the fact that as you approach 0, the number is getting so large that we cannot define what that number is. So the moment that you end up with a 0 at the bottom of the function becomes undefined. Okay? So that's what we're trying to say. So the process of the calculation is pretty easy, but most students don't understand what we mean by undefined. They just take what we say as gospel and run with it. So that's why I went through this whole process here of showing you why we say it's undefined. It is undefined because the answer after the division, or the quotient as them call it in math, the quotient is too large to write down on paper. Hence, we simply use the term undefined. All right? Following everybody?
Yes, sir.
Lovely. So then no. Lovely, Hanson. All right, so lovely now. So we'll look at this now. Now, let's say I gave you a function. Let's say I gave you g of x then, right? Let's say I give you g of x. And g of x works out to be 10 over, 10. All right, so 10 minus, 10 minus x divided by x. What number, I'm going to ask you this intuitively, what number would I need to put right here so that the function is undefined? What number do you think I would have to put there? Based on what I just explained to you, what number would I have to put right where that arrow is so that when I try to work it out, I'll get such a large number I can't define it? What number would I have to put there?
1, sir.
But 10 minus 1 over 1 can be defined because that is 9 over 1. And that's equal to 9. So it can be defined. So if you put 1 right here, so you can divide a number by 1. Try again.
-1, sir.
If you put -1, it can be defined as well, because 10 minus -1 divided by -1, of course we can divide a number by -1. What number can't you divide by?
Can't divide by 0.
Exactly. So what x have to be here, so?
0.
X has to be 0. Exactly. That's correct answer.
Okay.
X has to be 0, right? So basically what I'm trying to say is whatever is at the bottom have to be equal to 0. So in this case here, you just take whatever is at the bottom and set it equal to 0 and solve. In this case, there's nothing to solve because x is just 0. Okay? Next now h of x is equal to 5 minus 2x over 2x plus 1. Question now. I don't want the answer now. Tell me what you would do to get the answer. What number would I have to put right there so that when I work it out, I get 0? What would you do to find that answer? Come now, guys, talk to me now. What number would I have to put right here so that when I work it out, I get 0? How do you derive that solution? Nobody now help me? 0. But Latisha, if you put 0 there, 2 times 0, 1. Well, I'm gonna work out. Let me show Latisha say it can't be 0. Because if you say 0, Latisha, then 2 times 0 plus 1, that's going to be 0 plus 1, and I can divide a number by 1. So I can't 0. Try again. What number would I have to put there? If you try, guess it, I'll get it wrong, So that means there has to be a calculation process. I told you the process earlier, What did I do up here? What is it that I did up there so that I got my answer? What did I do?
So I was working, I get -1/2.
That is absolutely correct. -1/2. What did you do to get that answer, Miss Gentles? Guide them.
I use 2x plus 1 equals 0, and then I carry over the plus to minus, and then I divide it.
So 2x is equal to -1.
2x equal -1, and then x equal -1 divided by 2.
Correct. That's it. But I've been saying, what I've been saying, and probably you're not really interpreting what I remember. We want 0 at the bottom, That's what we want, We want 0 to be at the bottom. So in order for us to get a 0, what do you think you have to do? You have to make this equal 0. Because a 0 we want. So we want 0 to be at the bottom. So therefore, whatever is at the bottom of the function must be equal to 0. And you solve the equation. All right? So that is what you call an undefined function. Let's do one more. All right, so let's say we end up with something like this then. T of x is equal to x over the square root of x plus 1. And I want to find what number will make this function undefined. What would I do? What number would I have to put here so that the function becomes undefined? How do you work it out? Tell me, what will you do? I want 0 to be at the bottom. So what would I do to get a 0 at the bottom?
Make x -1.
Pardon me? Make x -1? Yeah, you are correct. X is -1, but I want the working out. You are correct. X is -1, but what's the working out? Because that's how you're going to get the 2 marks, They want to see the working out. So again, like I said before, you're going to take whatever is at the bottom and set it equal to 0. Now, how do we get rid of the square root?
By squaring it, sir.
Okay. So you square this, square that. You end up with this. So you end up with this square cancel the square root cancel the square. So you end up with x plus 1 equals 0. And like Akisha said, x will go equal to minus 1. That's it. So in summary then, ladies and gentlemen, in summary, for you to find the value of x that makes a function undefined, for you to find the value of x that makes a function undefined, let the denominator equal to 0. So that's the rule, guys. The rule is let the denominator, so let the denominator, where's my marker freezing? Equates to 0, equal to 0. All right? So that's it. Small little topic there. It's worth 2 marks, so I don't want you to dash it.
Sir, how would this appear on a test paper?
Just like that.
Oh.
So they'll give you a function and then they'll write it like this, right up here. So they'll give you a function or give you 2 functions and they'll write it like this. State the value of x for which f of x is undefined.
Okay, sir. Once, because that was my concern. You'll get the paper and tell you, sir, like, me don't want to just see the paper and then me don't know what me do. Yeah. So, but if they're going to tell you that it's to be undefined, then okay.
Yeah, man. Let me see if I could find a paper. Hold on, give me a sec. Let's see if I could find a paper that.
I think one
that
is in the test, the thing that you did last, the mock exam paper.
Oh yeah, because I put it there, but actually I want him to see it from an actual paper. I want him to see it from an actual paper that I didn't construct. See if we can find one real quick. Oh, see, there's a function here, but they've not said nothing about undefined. No, they've not said nothing about that. So function is there, but I don't see any with undefined. So let's go back. They're a little bit challenging to find now, because not every year it coming now. But we can hopefully we can find one real quick. You're not saying none come the year, day. Okay. Let's see if we can find one, May 2024. Oh, you guys are not seeing you're not seeing my screen, right?
No, sir.
No.
Right. Yeah. I'm trying to see if I can find one. Hold on. Oh yeah, none is there. It's gonna be a little bit challenging to find. There's so many papers, you know. I'm gonna look at 2 more to see if I spot any. So this is the second to last one. I see more functions again, you know. I'm not seeing the undefined function one. Oh, I know where one is. I think one is I think I know where one is. One is 2007. I remember that see one in 2007. I remember that's the first time I ever see it. I remember that I saw it somewhere. Maybe at the back of the paper or somewhere. Oh my lord. Was it 2007 or 2008? One of them. Inverse function g of 2. Give me a second, guys. Hold on. I really want someone to see it. Or I think it was 07, you know. It's important you guys get a chance to see it, because when you see it on the paper, you'll begin to believe it, All right, I'm not find it, guys. I thought it was 07, but it's not there. Oh Lord, I'm seeing all the functions, but I'm just not seeing the undefined one. I don't think it's the year I failed. I don't think I saw it that year. Let me see. May 2008. Let us see, let us see, let us see. Oh, lo. No, sir. Guys, me I look too much. I'm searching everywhere and I can't find it. So maybe one of them marathon class, you will go book up on one of them. But it's definitely there, though. All right, so as I said, Sam, is when you go on the actual paper, it's going to write it like this. F of x is whatever. State the value of x for which f of x is undefined. Okay?
Okay,
When I
sir.
find one, I'll send it to you. Yeah. All right, lovely. So let's move to our objective for tonight, which is going to be composite, sir. That means it doesn't come regular. It doesn't come regular, and even if it does, it doesn't come with any heavy marks. 1 mark or 2. So if it's a question that you wish to dash, you can dash it. All right, guys. So we're going to looking at this topic here. Composite function. So COM function. All right. So the word composite, ladies and gentlemen, the word composite implies something having more than one element. Now, back in grade 4 or grade 3 is when teachers, I expect that it's around that grade, give or take maybe grade 5 or 6, is when your teacher should have spoken to you about prime numbers. Not sure if you ever remember that teacher talking to you about prime numbers, numbers that has only two divisible factors, one on itself. In that same interim, a teacher should have said to you that a composite number is a number that's the opposite of a prime. For example, 2 is a prime number. Why is 2 a prime number? Because 2 can only be divided by 1 and 2. No other number can go into 2 exactly. 3 is a prime number because only 1 and 3 can go exactly into 3 without leaving a remainder. 5 is a prime number because only 1 and 5 can go into 5. 7 is a prime number because only 1 and 7 can divide exactly into 7. But watch this now. 9. 9 is not a prime number. Why? Because 1 has more than 2 factors. Therefore, 1 can go into 9, 3 can go into 9, and 9 can go into 9. So as long as a number can be divided by more than 2 numbers, the number is said to be a composite number. So once you have more than 2 things that can go exactly into the number is said to be composite. What are you hinting at, Mr. Peart? What are you trying to say? Composite means 2 or more functions joined together to make 1. So what do you mean by 2 or more functions? Basically, what it looks like is this. You're going to see like a 2 function here. Like it's going to say fgx, or it's going to say gfx, or you might see g squared x, or you might see f squared x, something like that. So when it's composite, you're obviously seeing 2 functions. Basically, what you're looking at here is f and g tied together to make 1 function. So f and g, notice how they're conjoined together. So basically what this means is that we have the g function that is inside of the f function. So together they become what is called a fg function. or a double function. Okay, so you have in here you have f function that is inside the g function. What this one means now is that you have the g function inside itself. So basically you have the function g that was merged into itself. It's going to make sense shortly. And this function right here means that you have the function into itself. All right, sir, I still don't quite understand what you're saying. Let's make it clear then. Don't worry, it's going to make a lot of sense shortly. All right, so here's some examples then, right? An example makes sense of this. I have two functions. One of the function is called f of x, and f of x then is equal to something like 2x minus 7. All right, something simple. All right, and then now I have another function which I'm going to call g, and g of x then is equal to 3x plus 4. All right, so I have two functions that's given to me. Now CSEC is going to ask you a couple questions. The question they're going to ask you is this. One, before we write one, they're going to say, write a simplified function, write a simplified function for 1, f gx and then the second one could be g fx. The third one could be f squared x, and the next one could be g gx. We're going to go through these one by one so you get the hang of it. All right, so look at the function that is given there. Now pay attention to my colors that I'm using and see how I'm utilizing the colors. I'm going to use the colors to guide you as to what exactly is going into what. So the first one, ladies and gentlemen, what this is really saying is that there is a function f, right? There's a function f that we must substitute the g function in it. So f gx means f with g in it. So what you're going now? I'm going to take, which color we must use now? Let's use blue, right? So what you're going now? I'm going to take the g function and put it into the f function. So watch now. I'm going to take this function right here. I'm going to send an arrow all the way right here. So that means I'm taking the function g and I'm replacing it with the x that is in the f function. So look at what I've circled. I've circled g. I've circled the function that's representing g. Notice that g is inside the bracket. Look at, what if I had f of 2? What would you do? If I gave you those two functions and I say work out f of 2, what would you do? You'd take the 2, not true? And you would replace the 2 with the x that is in the function, correct? So you'd end up with something like 2 times 2. Notice you do. You replace this x right here with what? 2, because it is in the bracket, not true? So f of 2 would mean 2 times 2 minus 7, which should end up with something like minus 3. All right, so that's when it's a number. But what is the confusion for a lot of people is that you're no longer substituting a number, you're actually substituting an expression. So what this means now, what you're going to know, I'm going to say f. I'm going to say f, open bracket, and tell me what is the g function. The g function is what? 3x plus 4. So basically what I'm doing here is that I am substituting 3x plus 4 with the x that is in the f function. Hopefully that makes sense. Come again. If you look at it, I broke down fgx into f square bracket g of x. Now notice what I've done. I've removed this g of x right here and I've replaced it with what is representing g of x. And so because just as so if I had f of 2, I'd put 2 where the x is in f. I'm going to do the same thing here. I'm going to substitute this x right here with all of this down here. So I'm putting the g where the x is in the f function. So I'm going to end up with 2 because the 2 is right here. And then this x right here now is going to be replaced with 3x plus 4. And then now don't forget the minus 7. Minus 7. And you're going to work that out. Now to work that out, you're going to simply just distribute 2 times 3x, 6x, 2 times 4, positive 8 minus 7. We're going to end up nicely with 6x minus r plus 1. All right? That's your answer. Any questions for that one?
Sir, we feel like me have one question, but we don't know what the question be yet.
All right, go and get it together and then ask me. Maybe in one of them examples here, as me I work them, you will get the answer to the question.
Sir, the x just disappear. So the x
Because
just
can you replace the x with one whole entire something right or so? This x you see right or so no? It gets
yes, sir.
replaced entirely by 3x plus 4.
Okay.
So if you look at it right here, so this here, so represent the x that was right here. So all of this thing right here, so all of this 3x minus plus 4 here replaces the x so you see up here, so. So that's you have the 2.
Sir, that x is fine, But so when you have the fgx there, so does that the x they did a kind of have me wondering.
Oh, this x right here.
Yes, sir.
Okay, yeah, man. It's just representing a function, man. That's it.
Okay.
All right, so look at this one now. What's going to happen now is, let me just erase these markings here. So what's going to happen now is the opposite we're doing now. So what we're doing here is that now we're taking what? The f and we're putting it into the g. So look here now. This becomes g of what is the function that represents f? 2x minus 7. So that is what we're substituting. So we're saying g of 2x minus 7. That means the x you see right here, so hold on there. The x that you see right here, that x right there, so what I've indicated in blue, that x will be replaced by all of this right here. Yes, Joshua, that's correct. Right there, so. So therefore, this is going to be equal to, g, sorry, this is going to be equal to 3, open bracket, and remember this x right here, so will be replaced by all of this thing right here. 2x minus 7. And do not forget your plus 4 right there, so. So that's why it's saying 3x plus 4. The x is now 2x minus 7. So this is going to be 3 times 2x is 6x. 3 times 7 is negative 21 plus 4. This works out nice to be 6x minus 17. And that's the answer. Any questions on those two? I'm giving you a minute to soak it in. All right, that's a minute. Soak it in. Moving on to the next one. Any questions you may have supposed to pop up by now. All right, now this one is tricky now. This one, f squared x. So many students over the years, even myself, even when I was a teacher, I used to misinterpret this question. As a young teacher, I wasn't taught this. If I was taught it, why it flew over my head. But f squared x, many persons, what they'll do is that they believe that this square thing here implies that you should square everything that is in this function. So what they'll do, right? What they'll do and what you will not do is that you're not going to say 2 squared x squared minus 7 squared. Please do not do that. For the life of me, do not do that. Don't do that. All right. Another thing that I've seen students do over the years is them say 2x minus 7 and put one square on it. So them say 2 squared is 4. Then them say x squared. Then them say 49. Do not do that. That is so wrong. All right. So please don't do that. So those two things, avoid doing it. I would rather you leave the question blank than do those two things. That's total rubbish. Now, what does f squared x mean? The f squared means f into f. So you see the square that you're seeing here is because of the double f right here. That's what the square implies. So the square is implying that the function was substituted into itself. Now, look at where my arrows are going to do now. Look at the arrow. So look at the green arrow. I'm going to take the function f and all of that thing that I've circled, I'm going to put it right back right there. So that's what I'm going to do. So I'm taking the function, which is the 2x minus 7, and I'm putting all of that thing that I circled in green right back where the x is in front of the 2. So I'm going to therefore end up with 2 open bracket, the function back itself, 2x minus 7. And then don't forget back the minus 7. Don't forget back the minus 7. So look now, it is really what? 2, this name x now, you know, x minus 7. See it here? 2x minus 7 up here. So therefore, we end up with 2 times 2x. That's going to be 4x. 2 times minus 7. That's going to be minus 14 minus 7. So you end up with 4x minus 21. That's the answer. 4x minus 21. Now, that's another way how they can write it. So here you can clearly see that they're asking you for GGX. So GGX is actually implying that you're going to take the function g that's up here. Let's just erase these markings and use a different color here. So you're going to take this marking here, you're going to take this thing right here, and you're going to place it right back into itself. Okay? So you're going to end up then with, back then with 3 times itself plus 4. So 3 times itself, which is 3x plus 4, and then plus back the 4. So you're going to end up with 9x plus 12 plus 4. So you end up with 9x plus 16. And that's your answer. Okay? That is your answer.
Sir?
Yes.
You know,
Yes.
scatter roses when you're gone out, but may I tell you the truth? You're one of the best teacher because all along, when I saw these type of function or this type of function, never understand it one bit. And before you even work it out, I was able to work it out on my own. You're just one of the best. Yeah.
Oh, thank you.
I'm giving it. If I don't get a grade 1, it's because I didn't want a grade 1. May I tell you?
Oh, God. My skin catch a fire a while ago. God. Thank you. You're not the only one who say it. Nisha say it all the time, man. Gali and a whole for them in
Yeah,
the class.
man. Trust me. Your teaching style is totally different. You make it so easy. So easy to understand. Yeah.
Thank you. All right. So,
sir,
yes, dear, go ahead.
the thing is,
Yeah, I know. I was just
I'm not
pulling
seeing
up
the screen.
Yeah, I know. I'm gonna pull up a function. So let me see how your confidence feel when you see it.
All right.
Give me a second. I'm gonna hold on to your question. I'm coming back to it. So now that you kind of get exposed to what is called composite function, how do you feel when you see something like this on a paper? Give me a sec. How do you feel when you see something like this on a paper? Give me a sec. How is it coming up? Okay. So when I go here and I go to see last year's paper, right? And you scroll down now, how you feel when you see this on a paper? Where is it? Where is it? What is going on? Lovely. How you feel now when you see that? You feel confident. Because you know what that means. This you don't know yet, but you're going to learn it shortly. Well, maybe not this class. Look at that. Lovely. You see that? Show that FGX equals that something here. So you're going to learn how to answer these type of questions when that time comes. Ouch. Okay? Right. Nicolita, go ahead. I'm pulling up at the board here. Go ahead, Nicolita.
Sir, it's the I don't understand how you get the well, I understand a part of it, but where you have this 3x plus 4 and then you have plus 4 again, I don't get to.
Okay.
Yeah.
All right. So look what's going on now. Remember, the function, the function that represents g is 3x plus 4, right? That's the function. So if I'm gonna put back this thing right here, right where see the arrow where the x is, I'm gonna put back my 3, replace this x with the thing we just circle.
Yes.
That just represent x, but 1 to the 4 here.
Okay.
Because that is the x me replace, The 3 remains and the 4 remains. But just change the x to a new function.
Okay.
Okay,
gotcha.
Oops. Okay. All right. So, what then? What then? All right. So, what if I gave you something like this now? Let me see your level of interpretation. Or what you think you're expected to do. If you get the answer wrong, just tell me what you think you're expected to do. If I give you this question here, and I say f of x is equal to 5x minus 3, and I give you g of x is equal to x plus 1 over 2. All right. Tell me, what do you think you're expected to do if you see something like f g open bracket yes, fg open bracket 1. And let's say that that's part 1. And let's say that I ask you now to work out g f of, let's see here now. All right. GF of I just figured number a while ago, you know. Hi. Let me just figure out a while ago. 5 to 10. Oh yeah. All right. So GF2. All right, perfect. What do you think? It's kind of giving a little bit of direct, and it's kind of giving a little bit of it's kind of giving a little bit of direct, because you're seeing the number to substitute, but you're also seeing the FG, which is giving a little bit of composite. Anybody has any idea what you think you might need to do? Any idea? Based on what you've learned so far, what do you think you might need to do? Anybody? Anybody want to guess? Okay, I'm gonna take too long to guess. Substitute the x with 1 in which function? Substitute the x with 1 in which function, Latisha? In FG. That could work. That's a harder way to do it. So are you then saying that we have to find FG first and then put 1 in there? Is that what you're trying to say? Maybe that's what she's trying to say. Maybe. All right. So, ladies and gentlemen, look at this. So, if and when you see this question is what we call a direct. This is what you call a direct composite function. So, what this means, ladies and gentlemen, 2 ways you can work it out. You can put the 1 into G. You're gonna get an answer. And when you get that answer, slide that answer back into F. You can do it that way. Let's do it that way and see what happens. So first I'm going to work out G of 1. And G of 1 is going to be equal to 1 plus 1 over 2, which works out nicely to be 2 over 2, which is equal to 1. So basically, G of 1 is 1. But now that we have G of 1, we're going to take the answer when we get to G of 1. In fact, you know what? Let me write it prettier. Hold on. Let me write it pretty. Give me a sec. I'm going to write it pretty. So what this means then is that this is saying F square bracket G of 1 close square bracket. That's what it's saying, you know. So I'm going to work out the red one first. I'm going to work out G of 1 first. So G of 1 is going to be equal to, so G of 1 will be equal to 1 plus 1 over 2. So where you get that from? Because the G, I'm going to put the 1 right here, so we put G there. So 1 plus 1 over 2, that works out nicely to be what? 2 over 2, which is near equal to 1. So G of 1 is 1. Now watch this now. We're going to say F of the result of G of 1. So we're going to say F of 1. So we're going to put 1 now. It's basically like what you call, it's a double direct function. And a double direct function is really a composite function. Because you put 1 and you directly substitute it into one function, and you take that result where you get and substitute it back into another function. So it's like you're doing 2 direct substitution, but it's coming across as composite. So F of 1 then works out nicely to be, remember, say we put the 1 right, so no, it is going to be 5 times 1 minus 3. That works out nicely to be 5 minus 3, which is equal to 2. All right, that's what you do with that. Now, using that information, what do you suppose I'm going to do here? Using what we just showed you a while ago, what am I going to do here? Anybody? I'm going to do what to what? Anybody? Anybody? Come on, guys, don't talk to me no, man. I'm not boring, so. Oh, no, I play silent treatment. All right, we have to play one silent game. I'm going to win. Are you guys not hearing me?
So we're hearing.
What happened? So, come, not tell me I'm not boring. I'm not so boring. Come. I'm not going to put 2 in a F,
So we're
man.
going to use it to, yeah.
I'm putting in a F, not true.
Yes, sir.
So F of 2 equals 5 times 2 minus 3. So that's going to be what now? 10 minus 3, which is equal to 7, not true?
Yes, sir.
So now you're going to take the 7 now and slide it into G. So therefore, G of 7 equals 7 plus 1 over 2. That's 8 over 2, which is equal to 4. Oh, Miss Song. Are you that? Nice, nice, nice. So if in case you see something like that, don't let them try to trick you. Yeah? All right. What would you do then? We have 5 minutes. What would you do then if you saw this? Let me set up now. Watch me on. Watch me on. All right. Let me see if we can trick on. H of x equals 5 minus 2x. Why be like 5 so much? Oh, God. G of x equals x, or in fact, you know what? I'm just messing up since the last part of the class. I'm corrupt on the brain now. X squared minus 9. All right. Now, what would you say I would have to do if I say, right? No, hold on, wait. Lord Jesus have mercy, wait there. Father Lord, hold on, wait. I must do this, oh God. I must do this. Yes. So, what then would be h of g of x equal to 10? Hey, Father Lord, I'm giving somebody $500 discount on the first marathon if you don't get this right. Me personally. So if you come on the day, if you're taking it, me tell you to charge you 5 bills less. If you get this right, we charge you 5 bills less. Come in. We should not want to take it on. Nothing will happen to you if you get it wrong, you know. But something will happen to you if you get it right. Who wants to brave up and get one $500 free? In fact, you know what? I'm going to buy that person lunch on that day. Now, you know, $500 small change.
I'm going
to buy somebody lunch that day. Who wants it?
Each would be
each.
2.
Hold on. What you say now, dear?
5 - 2.
5 - 2. We must write that down.
We're trying.
Oh, okay. Remember, now look at this thing, HGX equals 10. Interpret what that means. More stop your fam now, because you're not get no lunch, So if you say what you just say a while ago, you're not get no lunch. So nobody say it. Somebody, you have 3 minutes. Anybody? Nobody wants lunch that day? Well, when you see me eat my Domino's, I'm not even getting a piece or a slice that day. You're not going to watch me eating and I'm going to feel hungry. Who wants the free lunch? Who no want it? Hey, okay, all right. That's enough to give black people nothing, Come. Can you give them free food, they don't want it. Let's go. So we're going to work out HGX first. Not true? So watch how we go on now, people. We are going to take, watch me now. We are going to take G and put it into H. So we are going to take G over here, so, and slide it right there, so. We can't equal it to 10 yet. We have to get H of G of X first. So notice on my circle. I circle the what? The G. See it here? I circle the G. And I circle the G. Send me arrow and point it where I want it to land. I land it right in front of the 2 there, so. So now I'm going to end up then with, I'm going to end up with 5. Hold on, more black ink. 5, black ink, Mr. Peart. 5 minus 2 times x squared minus 9. And now remember, say that I got equal to what? 10. So look now, bring down the 5. Minus 2 times x squared minus 2x squared.
Okay.
Not true?
Yes.
Minus 2 times minus 9 is positive 18. And that I got equal
10.
to what? 10. Not true?
Yes.
Throw all of the numbers in over this now. We have minus 2x squared. Not true? Equal 10 minus 18 minus 5. Put all the numbers on the right and all the variables on the left. Not true? All right. And then we're going to end up now with minus 2x squared equals 10 minus 18 is minus 8. Minus 8 minus 5 is minus 13.
It's not add it.
Then add it now. Remember, say me carry over the positive 18 and me get minus 18. And me carry over the positive 5 and me get minus 5. So what is 10 minus 18? Minus 8. And what is minus 8 minus 5? Minus 13. So x squared now I got equal to minus 13 divided by minus 2. So minus times minus is positive. Not true? Remember, that's me the question in my head, so we're not getting any nice answer. So therefore, x then, ladies and gentlemen, is equal to the square root of 13. That's it. We don't need to go no further than that. If you want to write it for this one, it's up to you. That's fine. So it's x equals square root of 13 over 2. Okay? All right. So this is a challenge for you. All right? It's a challenge for you. I can't give you no money for this, Can't offer you no free lunch because you're going to AI it and come and act like say, I don't know if you do it. So they can't trick me. So don't worry yourself. Next class, ladies and gentlemen, we will be jumping into inverse functions and completing the square. We should have the inverse function tonight, but I was having too much fun with this question. So next sequence, I will be starting inverse functions and completing the square. Zahenia, write that down for me, love. Inverse functions and completing the square next week, Wednesday. And this brings us to the inverse functions and completing the square.
Mr.
Okay,
Peart,
sir.
can I
Yes.
ask you a question when you're through?
You mean when we start recording?
Yes, sir.
All right, give me a minute. All right, guys, it is the end of the class. See some of you guys on Saturday, and I'll see you guys next week. Have fun. Good night.
Sir.
Yes, sir.
Sir.
Sir.